At example 1, we're factoring to find all the zeros. How would I factor when I have 4 terms? Group them. So x cubed minus 3x squared plus x minus 3. So we're going to group the first two, group the second two. What's the GCF from the first group? X squared. So we're going to take out an x squared. What are we left with when we take out x squared? X minus 3. What's our GCF from the second group?
X minus 3. Oh, wait, 1.
1. We don't really have a GCF that we take out, but it'd still be 1. And then we're left with x minus 3. So now the two outside parts go together. So what would go into our first parentheses? X squared plus 1. And then the two inside parts to go together. So we have x minus 3. It asks us to find the zero, so we have to solve this all the way. So what would we do next? Set them equal to 0. So we have x squared plus 1 equals 0. X minus 3 equals 0. So in our first equation, we'll subtract 1. X squared is equal to negative 1. What would I do next? Square root both sides. So what will x equal? What's the square root of 1?
1i.
So 1i, which would just be I. But what am I missing when I take the square root? Plus or minus. Anytime you take the square root of both sides, you need the plus or minus. And then for the next one, I just add 3 to both sides. So x is equal to 3. So our zeros are positive and negative I and 3. Now for the second part of this question, it says find the complete factorization of p. So this just wants it in factored form. So we have to take each of our zeros and kind of work backwards a step and put it in factored form. So I had x is equal to I, x is equal to negative I, and x is equal to 3. How would I put these, bless you, into factored form? Subtract the I. So I have x minus I. What about the other one? X plus I and x minus 3. So notice how we just changed the sign. It's always x minus whatever your number is, but if you need to see it, you can just subtract I on both sides to get x minus I. Here we'd add I to both sides, and here we'd subtract 3. So in complete factorization, we just write it all together. So I have p of x is equal to x minus I, x plus I, and x minus 3. So part of our answer is just the zeros, and then part of it is in factored form. All right, the next page talks about multiplicity. So we've talked about multiplicity before. It's how many of those zeros we have. So here, what would, for x minus 1, what would x equal? X equals positive 1. And what would my multiplicity of that be? 3. I have 3 of them, so my multiplicity would be 3. For the next one, what would x equal? Negative 2. And how many of those do I have? 2. And then for the third one, x is equal to? Negative 3. And how many of those do I have? 5. Probably just for the multiplicity. Like it might have a box for the 0, and then it'll say multiplicity, and then another box. So you'd have to say, like, how many. All right. So the zeros theorem says that whatever our highest degree is in the polynomial, that's how many zeros we're going to have total. Some of them may be imaginary, some of them may be real, some of them might repeat. So if we look at when our degree is 2, our only solution here was 5, but it's 5 with the multiplicity of 2. So we have 2 solutions. So again, sometimes it might be imaginary, so that would be I and negative I, which would be 2 different ones. So whatever your highest degree is, that's how many answers you're going to have. So here we have to find a polynomial of degree 4 with the zeros I, negative I, 2, and negative 2. So we kind of did this before break, where it gives us the zeros. We have to come up with the polynomial, so we're working backwards. We're just going to ignore that p of 3 is equal to 25. It's just a way to help you check your work, but we want to work backwards. So my polynomial, I have 4 zeros, so x is equal to I, x is equal to negative I, x is equal to 2, and x is equal to negative 2. So in factored form, how would I write this? X minus I, x plus I, x minus 2, and x plus 2. Does anybody remember what we would do next to come up with the polynomial? FOIL. We want to multiply it out. So I'm going to start by multiplying the conjugates together because it'll make our work a little bit easier. So if you ever have the same number of opposites or conjugates, you want to start by multiplying those. So we're going to FOIL these out. So we get x squared. Yeah, when there's conjugates, there is a formula. I'm going to tell you right now. So it's a squared minus b squared. So you take your first term and square it. So it'd be x squared minus your second term squared, which would be I squared. You can FOIL this out. You'll get the same answer. X squared would just be x squared minus, what is I squared? Negative 1. So if I have a minus negative 1, what does that turn into? Positive 1. So x squared plus 1. When you FOIL these out, you'll get the same exact thing. But anytime you have conjugates, there is a shortcut. So you just square the first one, square the second. For the second group that we're going to FOIL out, we can use the shortcut again because they are conjugates. It's the same numbers, but the signs change in the middle. So our A here would be x, and our b is 2. So we have x squared minus 2 squared. Bless you. Bless you. So x squared minus, what's 2 squared? 4. So now I'm just going to multiply these two together. So I have x squared plus 1 times x squared minus 4. These are not conjugates. We actually have to FOIL them out. What's x squared times x squared? X to the 4th. X squared times negative 4. Then 1 times x squared. 1x squared. 1 times negative 4. Negative 4. Yeah. What would we do next? Combine like terms. So we have x to the 4th power minus 3x squared minus 4. And then we can't forget just to name our polynomial. It told us that this is p of x, so I'd just say p of x is equal to the polynomial. All right, let's do b. So to find a polynomial of degree 4 with zeros negative 2, 0, where negative 2 is a 0 of multiplicity 3. So I have x is equal to negative 2 and x is equal to 0. This tells me that I have a polynomial of degree 4, so I'm kind of missing some of my answers. What else do we know? X is equal to negative 2 has a multiplicity of 3, so we have 3 of them. So I have x is equal to negative 2, x is equal to negative 2, and x is equal to negative 2. So when we write this out in factored form, what would this turn into? X plus 2. X plus 2 and x plus 2. Because it said that we have a multiplicity of 3 at negative 2. So we've got 3 of them. And since our polynomial had a degree of 4, we know that we're going to have 4 x's total. So let's write all of this out. I have x plus 2 times x plus 2 times x plus 2. When x is equal to 0, how would I write that? Just x. Awesome. So I'm going to put that out front I'll worry about it at the end. What would I do next? Foil them. Let's pick 2 at a time and foil them together. Can I use the conjugate shortcut here? No, these are not conjugates, so you can't use the shortcut. You actually have to foil them out. So x times x would be x squared. X times 2 would be 2x. 2 times x is 2x. Plus 2 times 2 is 4. Let's combine our like terms. X squared plus 4x plus 4. Still have an x out front and an x plus 2. What would we do next? Do what? Foil it again. So now I'm going to take the second 2 and foil these 2 together. So it's a little bit more than just foiling. We just have to make sure everything in our first set gets multiplied to everything in the second. So x squared times x would be x cubed. X squared times 2 is 2x squared. 4x times x would be 4x squared. 4x times 2 is 8x. 4 times x is 4x, and 4 times 2 is 8. Let's combine our like terms. So we have x cubed. What would come next? 6x squared plus 12x plus 8. And then what would I do lastly? Awesome. I still have to distribute that x to everything on the inside. So we have x to the 4th power plus 6x cubed plus 12x squared plus 8x. And then we can't forget to name it. This is, it tells us q of x. That would be our polynomial. All right, so whenever we have complex zeros, so that might be either an I or a square root, they happen in conjugate pairs. So if one of my zeros, if I have x is equal to 2 plus I, it may not tell me exactly that I have another one, but anytime we have an I, we need the pair of it, the conjugate pair. So what's the conjugate of 2 plus I? 2 minus I. If it told me I had a 0 of x is equal to 3i, what's the conjugate of that? Negative 3i. Awesome. So they always happen in conjugate pairs. So it'll probably give you one of the imaginary solutions. You have to make sure you include the other one also. So let's do example 6. We're going to find a polynomial of degree 3. So it tells us that our degree is 3. That means our highest degree is going to be x to the 3rd power. So we know we have 3 zeros. One of them is 1/2. The other one is 3 minus I. So I have x is equal to 1/2. X is equal to 3 minus I. And what else? 3 plus I. Perfect. What would I do next? We want to put them into factored form. So if I have x is equal to 1/2, what would that be in factored form? Awesome. It'd be like x minus 1/2, but we know that we can move the 2 in front of the x, so we're not working with fractions. So that'd be 2x minus 1. For the next one, we have x minus, be super careful here because it's x minus this whole thing, 3 minus I. So what would I do to simplify this a little bit? Distribute the negative, so it turns into x minus 3 plus I. And then same thing with the other one. We have x minus 3 plus I. So we're going to distribute the negative. So that would be x minus 3 minus I. We know that when we have an imaginary number, they happen in conjugate pairs. So if 3 minus I is one of my zeros, then 3 plus I has to be another one. What would I do next? FOIL. So I FOIL this out. Which two do you think I'd want to start with? The conjugate ones. The second two here. Because I have a conjugate shortcut, so it'll make it a little bit easier. We know that we take our first term and square it minus the second term and square it. Now we have to be super careful here because our first term is that whole x minus 3 because that's the same thing in both of them. So x minus 3 is our first term and our second term is I. So we have x minus 3 squared minus, it's always minus in the middle, I squared. So I squared is negative 1, and what's minus negative 1? Positive 1. Now what do I do for x minus 3 squared? FOIL. We got to write it twice and FOIL it out. X minus 3 times x minus 3. So that gives us x squared minus 6x plus 9 plus 1. That plus 1 that we had from the I. So here we have x squared minus 6x plus 10. Any questions so far? Everybody with me? We all see how we did that? What do you think I need to do next? FOIL it with the other one. So we still have that 2x minus 1. So now we're going to FOIL these two together. So 2x times x squared would be 2x cubed. 2x times negative 6x is negative 12x squared. And 2x times 10 is 20x. The negative 1 times x squared is negative x squared. And we have plus 6x minus 10. What do we do next? Combine like terms, 2x cubed. This would be minus 13x squared plus 26x minus 10. And the very last step, what do I need to do? I got to name it. So we have to say p of x is equal to 2x cubed minus 13x squared plus 26x minus 10. So it says write the polynomial given the roots. So roots is the same thing as saying the zeros. We're doing the same thing here. So for number 5, I have negative 7 and 2 plus 3i. Am I missing any zeros here? What am I missing? The conjugate. So if I have an I need its conjugate pair. So I also know that. What's the conjugate of 2 plus 3i? 2 minus 3i is a 0. When I put this into factored form, what would I get? X plus 7. So we have x minus 2 plus 3i. So that turns into x minus 2 minus 3i. Yes. And then x minus 2 minus 3i. So x minus 2 plus 3i. From here, which two would we want to multiply together first? The conjugates. So you could either FOIL this out, just make sure each term in the first one gets multiplied to each in the second, or you could do your conjugate shortcut. Our first term is that x minus 2, and the second one is the 3i. We'll finish this one tomorrow with the rest of the notes. So just to redo number 5. So we want to put it into factored form. So what would the first factor be?
X plus 7.
Awesome, x plus 7. Now with the next two, The best way to think about it is that you're just changing the signs of both terms. So we always start with an x. So instead of positive 2, it'd be x minus 2 minus 3i. And then the next one would be x minus 2 plus 3i. So just change the signs of everything. Just like we did for the 7, when we have two terms, change the sign for both of them. Yes. Which two do we want to FOIL together first? The second two, the conjugates. So I'm going to do the conjugate shortcut, which is a squared minus b squared. Always minus in the middle. You can FOIL it out. When you FOIL it out, the i's are going to go away. So that's one way to check to see if you did it right. If you FOILed it out, the i's will be eliminated. You can just use your conjugate shortcut. All right, so let's do our shortcut. What's our a here? X minus 2, and what's our b? 3i. So we have x minus 2 squared minus 3i squared. For x minus 2, we have to FOIL it out. So we get x minus 4x, x squared minus 4x plus 4. For the 3i squared, what do we do there? Before we do that, we got to distribute the squared to it. So the 3 is being squared and the I is being squared. So it'd be 9i squared. Then we would change the I squared to be -1, which makes it a plus 9. So here we have x squared minus 4x plus 13. What would I do next? Awesome. We still have to multiply the first one to it. So x plus 7, we're going to FOIL together. So just make sure everything in the first set gets multiplied to everything in the second. We have x cubed minus 4x squared plus 13x plus 7x squared minus 28x plus 91. Last step is we're going to combine our like terms, and we can't forget to name it. So I'm going to call this f of x. X cubed, our x squared becomes plus 3x squared. Then minus 15x plus 91. All right, so let's look at 4. So am I missing any zeros here? What? Positive 5i. So let's write them in factored form. What would my first one be? X minus 2. What else? X plus 5i and x minus 5i. So we want to start by multiplying our conjugates together first. We can do our conjugate shortcut, a squared minus b squared. What's our a here? X, bless you. So x squared minus, what's our b? 5i squared. X squared is just x squared. Don't forget to distribute the squared to the 5 and the I. So this would be minus 25i squared. What is I squared? -1, so it changes it to a positive 25. So here we have x squared plus 25. What do we do next? FOIL the x minus 2 to it. So we get x cubed plus 25x minus 2x squared minus 50. Last step is let's just put it in standard form. Combine your like terms if you have them, but we don't here. So it'd be x cubed minus 2x squared plus 25x minus 50. And then name it. So we'll call it f of x. So let's look at number 6. What 0 are we missing here?
5 plus 2i.
-5 plus 2i. So the first term stays the same, the first number, the real part stays the same. the middle sign changes. So the sign in the middle changes. Let's write it in our factored form. What would the first part be? X minus 6. Then what?
X minus 5 minus plus 2.
Careful, because we flip the signs of both of them. So what after x, what would we put? You can put it in parentheses, but like I was saying for the last one, it's almost just easier. Change both the signs. So it turns into x plus 5 plus 2i. So you just flip the signs of both of them. Again, if you wanted to put it in parentheses, you can say x minus negative 5 minus 2i. And then when you distribute, you end up changing the signs anyways. So I would just kind of skip that step and just flip the signs. What would the next one be? X plus 5 minus 2i. Awesome. Let's start by multiplying our conjugates together first. So we're going to use our conjugate shortcut, a squared minus b squared. What's our a? X plus 5. Since that's the same in both of them, that's going to be our a. So we have x plus 5 squared minus, what's our b? 2i. So 2i squared. X plus 5 squared, write it twice and FOIL it out. We get x squared plus 10x plus 25. What do I do for the second part?
Square the 2 and the I.
Awesome. The 2 gets squared and the I gets squared, so it turns into 4i squared. What does I squared turn into? Negative 1, which changes it to a plus 4, so we have plus 4. So here this would be x squared plus 10x plus 29. Next step, we want to multiply the x minus 6 to it. So we're going to FOIL it out. Make sure everything in the first set gets multiplied to everything in the second. So we get x cubed plus 10x squared plus 29x minus 6x squared minus 60x. And then 29 times 6. 6 times 9 is 54, so this would be 174. Lastly, combine our like terms. We get x cubed plus 10x squared, no, plus 4x squared. Then minus 31x minus 174. And then we just need to name it. So it gives us one of the zeros, but it asks us to find all of the zeros. So if 3 plus 2i is a 0, do we know what another one is? 3 minus 2i, the conjugate. How many zeros total am I going to have here? 3, because it's x to the third power, so that tells us we're going to have 3 zeros. So we've got 2 of them. We need to find the third. So what we're going to do is put these into factored form and multiply it out to find out what polynomial this will give us. So in factored form, what would this be?
Minus 3 minus 2i.
And?
And x minus 3 plus 2i.
Awesome. So just flip the signs of everything. X minus 3 minus 2i and x minus 3 plus 2i. Now let's do our conjugate shortcut. A squared minus b squared. What's our a? X minus 3. So we have x minus 3 squared minus, what's our b? 2i squared. So we're going to FOIL out x minus 3. We get x squared minus 6x plus 9. What do I do for the minus 2i squared? Distribute the squared. So 2 squared is 4. So we get 4i squared. What does I squared turn into? Negative 1, so it makes it a plus 4. When Jaden comes back. So we get x squared minus 6x plus 13. So this is one of our factors. How do you think I could find the other factor? let's say I had something like 6, and one of my factors was 2. How would I find the other factor of 6? You divide. You would divide 6 by 2, so we're going to divide. So outside I have x squared minus 6x plus 13. And sorry, it has to be long division. You can't use synthetic division since it is a trinomial that we're dividing. Then we have x cubed minus 11x squared plus 43x minus 65. So we got to think back to before break when we did long division. What's step 1 with long division? We divide. X cubed divided by x squared. If I have 3 x's and I take 2 away, how many am I left with? 1, so x. What's step 2 of long division? Multiply. So we multiply x times everything out front. We get x cubed minus 6x squared plus 13x. What's step 3? Change the signs. So this becomes minus plus minus. So the x cubes cancel. 11x squared plus 6x squared would be negative 5x squared. And 43x minus 13 would be plus 30x. What do we do next? Divide again. So back, we repeat the same steps. Back to the top. What is negative 5x squared divided by x squared? Negative 5. What's next? Multiply. So we get negative 5x squared plus 30x minus 65. What's next? Change the signs and combine. 5x squareds cancel. What else happens? 30x cancels. What else? The 65s cancel. So what's our remainder? 0. When you do this, we know that this is a factor of it. We're finding another factor, so you're always going to have no remainder. If you do this part right in the beginning when you FOILed it out, and the division right, you're going to be left with no remainder if you do it correctly. So that's always one way that you can check your work. Everything will cancel. So it is kind of annoying because we have to do long division again, but you really are not doing it that much, and you can check your work by doing it because everything's going to cancel. Like, it's not like we had 100 steps of long division here. So if x minus 5 is a factor, what does that tell us that x is equal to? 5. So our 3 zeros are 5, 3 plus 2i, and 3 minus 2i. Questions? So same thing with number 8. If I have negative 2 minus 5i as a 0, what do I know another 0 is going to be? Negative 2 plus 5i. So let's put them into factored form. It always stays, the first number stays the same. The only thing that's changing is the sign in the middle. When we put it into factored form, what would it be? Awesome. X plus 2 plus 5i and x plus 2 minus 5i. Now you can FOIL this out if you want, or you can do your conjugate shortcut, a squared minus b squared. What's our a? X plus 2. So we have x plus 2 squared. What's our b? So minus 5i squared. Everybody with me so far? Any questions so far? X plus 2 squared, we want to FOIL it out. We get x squared plus 4x plus 4 minus 5i squared. What would I do here? Distribute the squared. So we get minus 25i squared. And what does I squared turn into? negative 1. So it makes it a plus 25. So we get x squared plus 4x plus 29. So this is our factor of it. How do we find another factor? Long division. So outside the box, I have x squared plus 4x plus 29. Inside, we put x cubed plus 11x squared plus 57x plus 203. So step 1 of long division is divide. X cubed divided by x squared, x. Step 2 of long division, multiply x times everything out front, so x cubed plus 4x squared plus 29x. Step 3, change the signs and combine. So x cubes cancel. This would be 7x squared plus 28x. What's next? Divide again. 7x squared divided by x squared, 7. Then we multiply 7x squared plus 28x plus 7 times 29 is 203. Last step, change the signs and combine. What do we notice that happens? Everything cancels. So always, always, everything is going to cancel. That's how you know you did it right. So we have x plus 7 as a factor. What does that mean that x is equal to? Negative 7. So these would be our 3 answers. So here we want to find the zeros. What would we do? We can try factoring by grouping. Group the first 2, group the second 2. What's the GCF from the first group? X squared. When we take out an x squared, we're left with x minus 8. What's the GCF from the second group? 1, because we don't really have one. So 8x minus 7. Are the inside parts exactly the same? No. So can I factor by grouping? No. So we got to try something else. How else could I find the zeros? Synthetic division. What are we doing? What are we dividing? What synthetic division? What are we doing? Yeah, synthetic division, but what are we dividing?
P over Q.
Yeah, perfect. P over Q. Factors of the last over factors of the first. So David, what are factors of 7?
1 and 7.
1 and 7. So we'd say positive and negative 1 and 7. So let's try it. We're going to do synthetic division. Inside the box, we have 1, negative 8, 8, and negative 7. What do you want to try first?
1 positive 1.
Let's try 1. We're going to drop down the 1, multiply, get negative 7, multiply, so it'd be negative 7, 1, 1, doesn't work. What do you want to try next? Let's try 7. Multiply, we get 7, negative 1, negative 7, 1, 7, 0. Does it work?
Yeah.
Yes, so one of our zeros is 7. That is one solution. How could I find more? How many zeros are we going to have total? 3.
You have to move down the x's to like that new
So if I start with x to the third power,
x to the second.
this would be x to the second power minus 1x plus 1. So x squared minus x plus 1. Let's see if this factors. Do we have 2 factors of 1 that add to negative 1?
No.
No. So if it doesn't factor, what do we do? What do we do? What do we do? Quadratic formula. On the homework, all these questions that we've been doing have what in the zeros? Before. Imaginary. They're all imaginary zeros. Almost all imaginary zeros. They all contain at least 2. So the homework ones are going to be the same. So I think for most of these types of questions in the homework, you'll have to do the quadratic formula. So let's just do the quadratic formula real quick to practice. Our quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So our a is 1, b is negative 1, and c is 1. So when we plug it in, we get 1 plus or minus the square root of 1 minus 4 over 2. So 1 plus or minus the square root of negative 3 over 2. Can I simplify this anymore? Awesome. 1 plus or minus I square root 3 over 2. So these would be our 2 other answers. So we have x is equal to 7, 1 plus I square root 3 over 2, and 1 minus I square root 3 over 2. These are our 3 answers. On WebAssign, you have to put the answers in separately. So you'd say 7, comma, 1 plus I square root 3 over 2, comma, 1 minus I square root 3 over 2.